Hello, hi, myself Dr. P. Shivaranjani, Academic Coordinator, Department of Graphics and Creative Design. So here we'll discuss about in 2D and 3D animation. Understand the necessary thing is color model. So first in the color model, we are going to discuss about a simple color chart that defines the range of color displayed in the color model by the help of RGB, CMY, CMYK, HSB, HLS, CIEL, that is A into B lab. So these are some of the examples for the color model. So here the RGB refers to red, green and blue, and CMY refers to KN magnetic yellow, CMYK refers to Kyan magenta, yellow and black, HSB refers to saturation, hue and brightness. HLS refers to hue, lightness and saturation. CELI refers to that is your length into A into B. The next thing is the color palette, a collection of solid color from which you can choose the color for filling and outline. In color profile, a description of the color handling capabilities and characteristics of the devices. In color separation, in commercial print, the process of splitting the colors in composite images to produce the number of separate grayscale images, one for each primary colors of in the original images. In the issue of CMYK image, 4 separation, one for cyan, magenta, yellow and black must be made. So the first thing we are going to consider is CMYK color. So here the CMYK color model, which is used in printing, uses the component like crayon, magenta, yellow, black. Crayon refers to C, magenta refers to M, and yellow refers to Y, and black refers to K. So the value of this component ranges from 0 to 100%. CMYK color model. In subtractive color models such as CMYK colors, that is, ink is added to the surface such as white paper. The color then subtract the brightness from the surface. When the value of each color component CMY is 100, the resulting color is black. So you can see in the figure, when red, green and blue is mixed together, you get the intersection point as black. When the value of each component is 0, no color is added to the surface, so the surface itself is revealed, in this case the white paper. The black K is included in the color model for printing purpose because the black ink is more neutral and darker than the blender equivalent amount of C, M and Y. In black ink produce the sharper results, especially for printing text. In additionally, black ink is usually less expensive than the colored ink. CMYK color model. Black is the resulting combination combining the 3 CMY color at the highest intensity. So that is shown in the figure. The next one is HSB color model. So HSB color model uses hue, saturation. H refers to hue, S refers to saturation, and B refers to brightness as the component for defining the colors. HSB is also known as HSV with the components of hue, saturation and values. The hue describes the pigment of the colors and it is expressed in the degree to represent the location on the standard color wheel. For example, red is the degree, red is in the degree 0, 0 is degree 0, and yellow is 60 degree, green is 120 degree, crayon is 180 degree, blue is 240 degree and magenta is 300 degree. So this refers to the combination of HSB color model. Saturation describes the vividness or dullness of the colors. The value of the saturation ranges from 0 to 100 and represent the percentage. The higher value, the more vivid colors. Brightness describes the amount of light white in the color. Like saturation value, brightness value ranges from 0 to 100, and to represent the percentage, the higher value, the brighter color. RGB color. So the RGB color model uses the component of red refers to R, green refers to G, and blue refers to B to define the amount of red, green, and blue light in the given color. In 24-bit images, each component is expressed the number from 0 to 255. In an image with a higher bit rate, such as 48-bit images, the value is greater. The combination of this image defines the single color. RGB color in a additive color model such as RGB color is produced at transmitted light. RGB is therefore used on the monitors where red, blue, and green light are blended in various ways to produce the wide range of colors. When red, blue, and green lights are combined at their maximum intensity, the eye perceives the resulting color as white. In the theory, the colors are still red, green, and blue, but the pixels on the monitors are too closer for the eye to differentiate the three colors. When the value of each component is 0, the significance there is an absence of light. The eye prescribes the color as black. The white is the resulting of combining the three color model at the maximum intensity. So here you can, in the intersection of three colors, you can get the white as the highest result. The RGB is the most commonly used color model because it allows a broad range of color to be stored and displayed. The next one is gray color model. The gray color model defines the color by using the only component brightness, which is measured in the various range from 0 to 255. Each grayscale color has equal value of red, green, and blue component of RGB color model. Changing a color photo is to gray creates a black and white photo. Color depth and texture mapping. The color depth of the image impact the range the color it can be displayed, while the texture mapping techniques allows 3D animator to apply a complex color pattern to 3D visual surface. Understanding this concept is vital for achieving a realistic texture in animation. Color palettes and mood. Choosing the colors is the crucial for setting the mood and tone of animation. Understanding the color psychology and its impact on the audience. Emotional response is the key for the creating compelling visual nativity. Color grading and post-processing. Effective color grading and post-processing techniques can be revert the visual effect quality of the 3D animation. Understanding how to use this tool like color, curves, balancing, and grading presence is essential for achieving a polished and professional look. Color management in 3D animation. Implementing the color management workflow ensures the consistent color representation across different devices and platforms. Understanding the color profile, calibrate, and the color space conversion is essential for maintaining the integrity of the final animation. Challenges and issues. 3D animator often faces the challenges related to color accuracy, color blending, and color branding. So for that, the solution provided is color correction in 3D animation. Color correction in 3D animation is the process of adjusting the colors of rendering animations to achieve a desired visual style or to correct inconsistencies or issues in the colors. Representation. It involves the manipulating of various aspects of colors such as brightness, contrast, saturation, and hue to enhance the overall look and feel of animation. Best software tools for color correction in 3D animation: Red Giant Coloristic Free, Adobe Premiere CC, Wondershare Flow.